Welcome to part 2 of this video. If you didn't watch the first one, I would recommend that you go back and watch that one, because that goes over more basic examples that you should understand before moving on to this video. So let's start with our first example. Ch3 Co Ch Br Ch2 OH. How do we draw the Kekule structure for this condensed structure? So obviously we start with the CH3. And then we have a carbon. But oddly enough, we have an oxygen, and then we have another carbon, and then everything else. So what do we do in this case? Whenever you see COC looking like this, it's going to mean that this is a ketone. A ketone looks like this. A ketone is an oxygen double bonded to a carbon, which is bonded to two other carbons. That's called a ketone. So now in this case, we have the carbon, right? To draw the oxygen, we would double bond it to the carbon. And then we would continue on with our structure. So we put C, and then hydrogen and bromine. So the hydrogen and bromine go on the carbon. And then CH2. And OH at the end. So that's how to recognize that you have a ketone in your formula. The next example, we're going to have CH3, CHF, CHCl, and CHO. Now we've seen OH, but what is HO? So let's find out. We have a CH3 on the left side. We have a CHF, which means we have a carbon with a hydrogen and a fluorine. And then we have a CHCl, so that would mean a carbon with hydrogen with a chlorine. And at the end here we have a carbon, so we know that to attach it to this carbon. And then how do we figure out HO? So whenever you see HO or CHO together, this is going to be an aldehyde. An aldehyde looks like this. It's similar to a ketone in the sense that you have an oxygen double bonded to a carbon, but in a ketone, the carbon is attached to two other carbons. In an aldehyde, one of the carbons is replaced by a hydrogen. So ketones are always going to be at the end of a molecule. So it's going to be always at the right end or the left end. And so in this case, to draw the aldehyde, we draw, if you want to draw the hydrogen, you would go like that. And then to draw the oxygen, you need two bonds to make it so that this carbon has 4. So you draw 2. And there is your structure. In the next example, we're going to look at another similar compound. So how would you draw the Lewis structure for this one? What exactly is COOH? It looks kind of confusing. So to draw this, we obviously draw the C. And then whenever you have CO, it's usually going to be a carbonyl group, meaning that it's going to be C carbon double bonded to the oxygen. That's called a carbonyl. And then you can see here that we have an OH. So that OH is going to go on the left side. You can draw it as HO if you want, just to keep the order. And so we have 2 oxygens, a carbon, and a hydrogen, which is exactly what we have here. So we have this out of the way. That right there is called a carboxylic acid. A carboxylic acid is whenever you have an oxygen double bonded to a carbon, and in ketone it was bonded to a carbon and a hydrogen, but instead of being bonded to a carbon and a hydrogen, it's going to be bonded in carboxylic acids. It's going to be bonded to a carbon, but also an OH. So that's how you know that this is a carboxylic acid. So whenever you see COOH at the end of a molecule, you know that you're going to have a carboxylic acid, and it's going to look something like this. And then this right side of the carbon just continues on the carbon chain. So you have CHCl. So we'll draw that, and then we have CH2. And then we have C. We have 3 bromines on the carbon. So there you go. That is how you draw that structure. Let's go over more examples that have carbonyl groups. So we're going to go CH3, CHI, CH2, COO, CH3. So we start with the CH3, the left side. And then we have a CHI. Now the I means it's iodine, which is a halogen. So then you have CH2. And here's where it looks complicated, but it's not that complicated. We have a COOC. What exactly does that mean? So whenever you see this, it is going to be an ester. An ester is a carbon that is double bonded to an oxygen, and then one end is going to be attached to other carbons, and this can go on, but the other end is attached to an oxygen, which is then attached to more carbons, and this can also go on. So that's what an ester is. So in order to draw it here, we have a carbon. So we draw the carbon. And then the first oxygen is the one that's double bonded to it. And then the second oxygen is attached directly to the carbon with a single bond. And then we have a CH3. So that CH3 attaches to the oxygen. So notice how the oxygen usually has 2 bonds. Here it has 2, and then here it has 2 as well. So it's neutral, and it fulfills all of its electron requirements. Next example, let's look at CH3, CHBr, O, CH, Cl, CH2F. So what do we have in this situation? We can start by drawing the CH3, as always. And then we have CHBr, which looks like a normal carbon chain so far. But then we have a random oxygen in the middle, right? What does that mean? So if you have just an oxygen in the middle of a carbon chain like that, it's going to be called an ether. An ether is when you have an oxygen which attaches to 2 carbons, and those carbons can go on and do whatever they want later on, but the important thing about an ether is that it has this structure in it, and that's what we have here. So if you continue the structure, we have CHCl, which is this. So you can see we have oxygen bonded to 2 carbons, which is the same thing as we have here, and it's called an ether. Then we have a CH2, and then we have a fluorine. So that's part 2 of the video. Examples that are a little more complicated. I hope that was helpful. If you have any questions, leave them in the comments. Thank you for watching.